Hello, this is Brother Kromar from the Math Department at BYU, Idaho, and I'll be covering a couple of things on how to do independent samples t-test and Way Anova in R. So first of all, I'm going to import an SPSS data set and put it into R. So I'll just call it data set here. And it'll ask me to override it since I did something earlier with the data set. So then what I'm going to do is I'm going to go to song length data. So I'll click on that and then, or double click on that, and then if I go to view data set, you'll see I have two columns. The song length column, the length of the song in seconds, and music type. We have R&B and we have alternative type music. Okay. So then what I'm going to do is I'm going to go to statistics, I'm going to go to means, and I'm going to go to independent samples t-tests. Okay. Now, here we're supposed to pick the grouping variable. In this case, it's R&B, the music type, which is R&B versus alternative. And notice here, it just automatically picks this because it's the only one that appears to be a grouping type variable. Now, the response variable, response variable has to be quantitative, and the only quantitative variable was the song length, and so it automatically picked that. Now, there's three options here that we have. We can determine if it's a one-sided or two-sided test, the level of confidence for a confidence interval, if we're going to, and we're going to assume either equal variances or not. Now, normally I don't assume equal variances, so I'll just leave that at no. We'll keep the level of confidence at 0.95, and we'll just assume to be to do a two-sided test. Now, we need to keep track of which is the higher mean when we run the analysis, especially when we have to do a one-sided test. Okay, so I'm going to click on OK, and then here are my results. Here's my test statistic, my degrees of freedom, and my p-value. Notice here we have degrees of freedom that is not a whole number. And that's what, when we do something which is called the Sadorth weight approximation, we'll get degrees of freedom that's not a whole number. Here is restating what our alternative hypothesis is, basically what our test is. And here's our confidence interval, and here are the two means. So it looks like R&B has a slightly higher average than alternative here. Okay. So then the next thing we'll do is let's do a one-way ANOVA. So I'm going to grab a data set that lends itself to do a one-way ANOVA. So I'm going to go to import from an SPSS data set. I'll still call it data set here. You can call it peanut butter for all I care. It doesn't matter. So I'm going to overwrite this, and I'm going to go to what's called the Pumpkin Chunkin data. Okay, so let me find that here. Pumpkin Chunkin. Where are you? Oh, there you are. Pumpkin Chunkin. So I'm going to double click on that. And I view the data set. Now, first of all, now we're checking to see if the year, in terms of the average distance, how much a pumpkin gets sent or thrown using catapults, if it's different for the different years. Now, notice here that both of these columns are numeric. The year variable is going to be what's called the grouping variable. But since it's numeric in R, we have to do something about that. So the very first thing we have to do is we have to go to Data, and we have to go to Manage Variables in a Data Set, and then convert numeric variables to factor. So what I'm going to do is that I'm going to click on Year, and you can either supply level names or use numbers. I'm just going to use the numbers. It doesn't matter. And then we're just going to call it the same variable name. It doesn't matter. I'm just going to overwrite the variable name. And so overwrites, I'm just going to overwrite year, so now it's going to be a factor variable. So we needed to do that, or else if we didn't do that, then it's not going to work. In fact, our commander, what it does is that you do all these different things, clicking buttons, but up here is where you can see the coding. And when we did change the numeric variable into the factor, this is basically the coding that it used. Okay. So then the last thing I'm going to do is I'm going to do statistics, I'm going to do means, and then I'm going to do one-way ANOVA. Okay. And so the group variable is going to be year, and then the response variable is distance. Okay. And if we want to, we can do a pairwise comparisons and means, and I'll just click on that just for fun. And then we click on OK, and then this already exists. We're going to override it. Sure, we'll override it. And then we have a couple of things here. So here, this graph is comparing the difference between, it's a pairwise comparison of all the different years to see if there's any differences. If 0 is not in the confidence interval of any of these confidence intervals, there's a difference somewhere. In this case, this almost made it, but not quite. So it looks like there really doesn't seem to be much of a difference. If we look at our output, what we can see here, in fact, we have some more output where we can see if whether or not there's a difference. In fact, this here is graphically shown here, these confidence intervals. Okay. But then ultimately what I want to show you here is the Anova table. So this here is our test statistic, this is our F statistic here, and this is our p-value. And if we had a level of significance of 0.05, we wouldn't reject it. Now these symbols here represent at what levels would we reject the null. So say for instance if we had a p-value of if we had a level of significance of 0.001, if we have double asterisks here on the right, that means we reject the null at if alpha is equal to 0.001. But since our p-value is 0.06, we wouldn't reject the null unless we get to this point right here. Okay. Then I believe that is all. We just a couple more things here. Here's the means and standard deviations and sample sizes for each of the 4 groups. And I think that is pretty much all I want to cover for how to do independent samples and ANOVA using R.